Okay, so I do want to take a little bit of time at the end of this hour to answer any questions on the test. You guys all should have got it back now. If you didn't, send me an email and I'll reply with your test attached to it for those of you in Richmond. Otherwise, everybody here should have theirs back. I will answer a question or two on the test here at the end of the hour. Anyway, we're going to continue on talking about our angles and triangles and stuff like that. But before we do that, I want to review that symbol there. What is that symbol? We're used to it being called square root. It actually is called the radical symbol. And one of the things it can do is a square root. When it's written like this, it does mean square root. It can be used for other things. In fact, we could do like this, where there's a 3 there. Now it's a cubed root or a third root. Or it'd be with a 4 in it. Now it's a fourth root. Technically, even though we don't write it there, there's a little 2 there. That 2 is what makes it a square root. Now, we don't write it. We just leave it off because without that number there, we assume it's a 2. But what does the square root really mean? Not divided by itself, but what it's asking is to reverse another operation. All of our operations come in pairs. If I just pick a number like 17, if I add 4 to it, I get 21. The definition of subtraction is the operation that will reverse addition. So if I take my 21 and I subtract 4 from it, I get back to 17. Likewise with multiplication and division. Let's start out with like 9. Let's say I multiply it by 3, I'm going to get 27. The definition of division is the operation that reverses multiplication. So I take my 27 and divide it by 3, I get back to 9. Well, we had a fifth operation that we looked at, and it was a power. 7 squared, 7 to the power of 2 is 7 times 7, or 49. The square root is the operation is defined to reverse the power of 2. So what this is asking us, the square root of 49 is asking us what number squared equals 49? 7. Perfect. Just like here, 27 divided by 3 is asking us what number times 3 equals 27. Now 7 is an answer, but there is another one. Is there another number that squared would equal 49? Negative 7. A negative 7 times a negative 7 would still be a positive 49. Now, in most cases, when we square root something, we're dealing with positive numbers. We want the positive answer. But just be aware that there is that second answer there, that negative possibility. So if I ask you for the square root of 9, what is the possible answers? 3 or negative 3. Or the square root of 16? 4 or negative 4. How about square root of 324? Okay, I don't expect you to have that one memorized. How do you do a square root on your calculator? Most of your calculators, you have to use the second or shift key. And then there's an x squared key on it. And above that is the square root key. So most of your calculators do second, square root, or shift square root if you have a Casio. Then you have to type in the 324 and hit equals. 18, very good. Some of you, if you have a one-line display calculator, may have to enter it backwards, where you type in the 324 first and then hit the square root key. So I'm going to have you guys try a couple. What's that? It's giving you an error. Let me see your calculator once. Hold it up. So on yours, you do second, then x squared, then 324. Did it work that time? You're welcome to. Okay. By the way, this is where many of your cell phone calculators start to break down and not work so well, because they might have a square root key, but they won't have a third or a fourth root key and stuff like that. So let's have you race me on one. The square root of 1,024. Everybody get 32? Square root of 15,625. Cool. Everybody get 125? You're obsessed now, huh? Gotta beat him. Square root of 729. I may have done these a few times before.
You have the answer.
Actually, no, I don't have any of them. I don't have any of them wrote down.
Well, you just know it.
There are certain. I've told you guys about. There's patterns in numbers. Once you see the patterns, the calculations are easy. Square roots are the same way. I'll show you the little trick here. 729 is 3 to the power of 6. A square root of 3 to the power of 6. Square root, you divide the power in half. So 3 to the power of 3, which is 27. Same with the square root of 15,625. 625, or 15,625 is 5 to the power of 6. So the square root of that is 5 to the power of 3, or 125. Yeah. You don't need to know that. Like I said, there are little patterns. 1,024 is 2 to the power of 10, so the square root is 2 to the power of 5, which is 32. Yeah, I bet you're all happy you know that now, right? I'll race you to this one. Square root of negative 121.
Can't be done.
Can't be done. Why not? Because it's a negative. What number squared equals negative 121? Well, squared means times itself, right? Yeah, to get a negative number, you have to have a positive times a negative. Well, that wouldn't be times itself. So there is no way to do the square root of a negative number, because nothing squared is ever going to be negative. Everything squared will be positive. This is actually going to come into effect on your calculators. We've mentioned this before, but if I take negative 6 and I square it on your calculator, try that once quick. Many of your calculators will try to tell you it's negative 36. It is not. Anything squared. Negative 6 times negative 6 is a positive 36. What do you have to do? Parentheses around it. What's happening is your calculator is squaring the 6 and then applying the negative to it after it's squared. The parentheses make the calculator square the negative 6, and then it will be a positive 36. So be careful with those. How about this? Square root of 0.16. It is 0.4. Now this is counterintuitive. When we square root something, don't we get an answer that's smaller? I mean, the square root of 729 was 27. Square root of 15,625 was 125. How can we square root something and get something that's bigger? But remember, it's because it's squared. 3 squared, of course, is 9. 2 squared is 4. 1 squared is 1. Well, right here is our break-even point. We square 1, we get the same value. It doesn't get bigger or smaller, does it? 0.5 squared is 0.25. It got smaller. 0.2 squared is 0.04. 0.05 squared is 0.0025. Remember, when we multiply two decimals, we count the number of decimal places in the problem. That's how many decimal places in our answer. So 1 decimal times 1 decimal gives us 2 decimal places. 2 decimal places times 2 decimal places gives us 4 decimal places in our answer. When we square something that is between 0 and 1, we get a result that is smaller. So therefore, if we square root something that is between 0 and 1, we're going to get an answer that is bigger. The square root of 0.0049 is 0.07. Much bigger. So keep that in mind. How about the square root of 1.44? Now, before you punch this in, bigger, or will it be bigger or smaller? It's going to be smaller. 1.44 is bigger than 1, so the answer will be smaller, and it will be 1.2. How about square root of 2.56? 1.6, perfect. Well, your fraction calculators will do this for you, but let's see it why that works out this way. Square root of 25 over 49. What's that? 5/7. Perfect. That's going to be 5/7. Exactly. If I were squaring 5/7, it's just 5/7 times 5/7. Well, because when we multiply fractions, we multiply the numerators, or multiply the names, or counts. 5 times 5 is 25. Then also combine the names. 7 times 7 is 49. All we're doing is taking 5/7. We're squaring the top and we're squaring the bottom. 5/7 squared is just 5 squared over 7 squared. The square root is reversing that, and that is the same thing. It's just the square root of 25 over the square root of 49. So 5 over 7. So if I have the square root of 9 over 16, that's going to be what? 3/4. The square root of 9, which is 3, and the square root of 16, which is 4. Now, of course, it could also be negative 3/4, but we're going to let that go. We're going to let the negative possible result go and just concentrate on the positives. So you might be wondering, why am I reviewing this when we were talking about angles and triangles? We're going to talk about a special type of triangle right now where we have a right angle in our triangle, otherwise known as right triangles. And we're dealing with right triangles. Of course, any triangle, the definition of triangle is 3 sides. So our triangle has 3 sides, but 2 of them are called legs. The legs make the L of the triangle. They are the 2 sides that touch the right angle. So there's a leg and there's a leg. The 3rd side is called the hypotenuse. It is always the longest side of the right triangle, And it is always always the side that is opposite the right angle. By opposite, I mean across from. In other words, it does not touch it. We label our sides using the letters A, B, and C. Letters A and V are used to label the legs. C is used to label the hypotenuse. Well, a couple thousand years ago, a man by the name of Pythagoras came up with the Pythagorean Theorem. Yes, I can't spell. And his theorem stated that if you have a right triangle, sides A, B, and C, the length of side A squared plus the length of side B squared equals the length of side C squared. And this is actually a very, very easy theorem to prove. There's several ways of demonstrating this. I'm going to show you one of the simplest ways. Let me do this a little bit better. Where are you? There you are. So I put these triangles together here. And you can see what I've created here is a square. So I'm going to go back to my pen so I can draw here. I have created a square right here with 4 right triangles that are identical. Here's my right angle. I'm going to call this side A, B, and C. So this will be side A, B, and C. A, B, and C. A, B, and C. Now, based on what we know about triangles, if this is a right angle, we know that this angle and this angle have to add up to how much? Well, the three angles add up to 180. If this is 90, the other two have to add up to 90, right? We know here that these 3 angles have to add up to 180 because it's the line here. And these 2 we just said add up to 90, so this is 90 degrees. It's a right angle. The reason I'm saying that is that tells us that this is a square and it is an area of C squared, right? So in this square, the big black square, everything that's not covered by the triangles has an area of C squared. Now I'm going to move some triangles around. I'll move this one right here. This one over here, and this one comes down here. Now, the triangles still cover the same amount of space, right? So the amount that's uncovered would still be the same amount of space, correct? This is side B, this is side A. This is side A, this is side B. This area is B by B or B squared. This area is A by A or A squared. So A squared plus B squared equals C squared. Relatively simple to show. So now the question is, how do we use it? Well, let's say this is 12. We're going to leave inches and feet off of it. We're just going to put numbers. So let's say that is 12, 16, and we'll call this X to find X. What 2 sides are my legs? 12 and 16. So I'm going to call those A and B. Therefore, X must be the hypotenuse, side C. So my formula, a squared plus b squared equals c squared. For a, I'm going to put in 12. So 12 squared plus, for b, I'm going to put in 16. So 16 squared equals, I'll put in for c, x. So x squared. What is 12 squared? 144. What is 16 squared? 256, right? That equals x squared. Now, 144 plus 256 is 400. Perfect. 400 equals x squared. Then what? Square root the x squared to get x. Square root the 400 to get 20. X is 20. So this is 20 units here. Make sense?
No.
No? Let's do another example. So this is 10 units. This is 24 units. We'll call this x over here. Now again, which two sides make up the legs? Whichever two make the right angle. Very good. So in this case, that'll be 24 and 10. So it doesn't matter which one I call A or B. So I'll call this one A, this one B. That means side C has to be the side associated with the x. So again, A squared plus B squared equals C squared. Now I'm going to substitute in. A is with the 24. So A squared becomes 24 squared. B is associated with the 10. So B squared becomes 10 squared. And C is on the same side as the x. So C squared becomes x squared. Then what? Well, 24 squared is 576. 10 squared is 100. That still equals x squared. We combine 576 and 100, of course, is 676. And then
26.
we square root. We get 26. You are correct. 26 equals x. So this is 26 units here. In your notes, find side x. So my legs are the 8 and the 15. So call those A and B. My hypotenuse is x. So call that C. A squared plus B squared equals C squared. So it becomes 8 squared plus 15 squared equals x squared. Then what? 8 squared is 64. 15 squared, 225. So we combine those to get 289 equals x squared. And then
X squared equals 17.
square root it to make 17 equals x. Very good. How many of you got that? Cool. See you later. Oh, let's do this. That ain't gonna be just what I want. We'll do 16 here. 65 there. Find x. Try that in your notes. Sides. X and 16 are the legs, so I'll call those A and B. 65 is that hypotenuse, so that'll be C. A squared plus B squared equals C squared. Most people make this mistake right out of the gun, using 16 and 65 for A and B. X is one of the legs. So this is going to be x squared. I replace the a squared. Plus b is going to be 16. So 16 squared. And c is the 65. So 65 squared. So x squared plus 16 squared is 256 equals 65 squared is what, 4,225? And then subtract. Yeah, we're solving the equation. Subtract 256. This is 3,974. No, 69. Thank you. So x squared equals that, and yes, we square root that. X equals 63. It's too close to the 65? Yep. I can show you something even more weird than that. Let's say this is 21 units. This here we're going to call 121 units. Or sorry, not 121. 221 units. Find x. Yes, I do have to include that there's a right angle right there. Good call. So A, B, C. So 21 squared plus x squared equals 221 squared. 21 squared is 441. 221 squared is 4884. One. Yeah. Sorry. We subtract the 441. 48,400. Yep. And we square root it to get 220. The bigger this number is, the bigger this one has to be to give us a significant change. The bigger this one has to be to give us a significant change here. It's very common to have ones here that are just 1 unit apart if this side is small. Like, oh heck, 35 is what? No, I can't think. So if you do this one, 21, 23, and 35, and this 21, 22. Okay, well, enough of that. I'm going to ask you an extra credit question here. We're going to talk about Mike. Mike's going hunting. And Mike leaves hunting camp in the morning. X marks the spot, right? From hunting camp, he walks 9 miles due south. At which point Mike turns and walks due west for 12 miles. And Brown knows points if you can tell what I'm drawing. Horse.
Bear. That's a bear.
That's a bear.
Bear.
That's a bear.
Well, I thought it was.
Horse.
I thought it was.
At which point he shoots a bear. I know it's kind of morbid with the blood. Mike realizes that he is still exactly 9 miles from camp. Here's your extra credit question due next week when you come to class. Or not next week, next Thursday when you come to class. You have to be able to prove it to me. What color is the bear? So there is a new quiz due tomorrow. That is Wednesday at 11:59 p.m. And there's a new homework due Thursday in class.
See that right there? That kind of problem is what math above this level looks like to me.
The bear.
I mean, is he like in Wisconsin? Is he in Alaska?
That's not a given part of the problem.
But those are all questions you need to answer.
Not really.
I could say he's
The
a
pro-
brown bear.
the problem
He's a
answer-
black bear.
The problem answers the question for you.
Oh,
There's a reason it's a math question. Okay, guys. There's the computer lab next door is open if you want to work on your homework. Otherwise, we'll see you on